Hello, welcome to today's class. In today's class, we will talk about 4 variable Karnaugh maps. In the previous two class, we have seen 2 variable and 3 variable Karnaugh maps. In today's class, we will look at 4 variable Karnaugh maps. So we will first start with the truth table, which shows the 16 rows that we have in a 4 variable truth table. So if we have 4 variables, the truth table will have 16 rows, and this diagram shows the input combination for each of the 16 rows. So the first row corresponds to the case where the variable x1, x2, x3 and x4 is equal to 0, 0, 0, 0, which actually is minterm 0. And the next row corresponds to the case where x1, x2, x3, x4 is equal to 0, 0, 0, 1, and this input combination corresponds to minterm 1, and so on. All the 16 rows are listed. Now the diagram here shows how the Karnaugh map of a 4 variable Boolean function looks like. So as you can see from the diagram, we have 16 cells in the Karnaugh map for the 4 variable Karnaugh map, and each cell actually represents one of the row in the truth table. It represents one of the input combination. Now as you can see, the variables x1 and x2 they are represented along the columns, and the variable x3 and x4 they are represented along the rows. So now the first column here represents the case where x1 and x2 is equal to 0, 0. So all the 4 cells in this column will have x1 and x2 equal to 0, 0. So in the first cell, the value of x1 and x2 will be 0, 0. In the next cell, value of x1 and x2 will be 0, 0, and so on. The next column represents the case where the value of x1 and x2 is equal to 0, 1. So again, all the 4 cells in this column will have x1 and x2 equal to 0, 1. So the first cell in the column will have x1 and x2 equal to 0, 1. The next cell will also have x1 and x2 equal to 0, 1, and so on. Now the next column corresponds to the case where x1 and x2 is equal to 1, 1. Please note that these columns do not represent the value of x1 and x2 equal to 1, 0. So the first column was 0, 0, the next column was 0, 1, and the next column is not 1, 0, it is 1, 1. And it is done this way so that only one of the variable changes when we move from one column to the other. As you can see, in this column, in the second column, the value of x1 and x2 is equal to 0, 1, and in the next column, the value of x1 and x2 is 1, 1. So variable x1, which was 0 here, is 1 in the next column. So variable x1 is changing from 0 to 1, whereas x2 is equal to 1 in the second column and is also 1 in the third column also. So x2 do not change. It's only x1 which is changing. The same thing can be noticed when we move from column number 3 to column number 4. In that case, variable x1, which is equal to 1 in the third column, is also equal to 1 in the fourth column. So variable x1 is not changing between the two columns, whereas x2, which is 1 in the third column, is equal to 0 in the fourth column. So x2 is changing from 1 to 0. So we see that as we move from one column to the other, only one of the variable changes. If we would have put this column to represent x1 and x2 equal to 1 0, then we can see that when we move from column 2 to column 3, both the variables would have changed. x1 would have changed from 0 to 1 and x2 would have changed from 1 to 0. So the third column represents the case where the variable x1 and x2 is equal to 1 1. So now all the 4 cells in this column will have the value of x1 and x2 equal to 1 1. The next column represents the case where x1 and x2 is equal to 1 0. So again all the 4 cells in this column will have x1 and x2 equal to 1 0. So the first cell x1 and x2 will be equal to 1 0. In the next cell, in the next cell, in all the cells the value of x1 and x2 will be equal to 0 0 in this column. Now along the rows, the first row corresponds to the case where the variables x3 and x4 is equal to 0 0. So in all the 4 cells along this row, the value of x3 and x4 will be equal to 0 0. So in the first cell already x1 and x2 is equal to 0 0, and now x3 and x4 will be also equal to 0 0. So this first cell represents the case where the variable x1, x2, x3, x4 is equal to 0 0 0 0. In the next cell, x1 and x2 is already equal to 0 1, and now we say that x3 and x4 will be equal to 0 0 in this cell. So this cell will represent the case 0 1 0 0. The next cell will represent the case 1 1 0 0, and the next cell in this row will represent the case 1 0 0 0. Now the next row corresponds to the case where the variable x3 and x4 is equal to 0 1. So all the 4 cells in this row, the value of x3 and x4 will be equal to 0 1. Hence the first cell where x1 and x2 is already equal to 0 0, and now if x3 and x4 is equal to 0 1, this cell will represent the case where the variables are equal to 0 0 0 1. The next cell will represent the case where the variables are equal to 0 1 0 1, then 1 0 0 1 and 1 0, sorry 1 1 0 1 and then 1 0 0 1. Now the next row corresponds to the case where the variable x3 and x4 is equal to 1 1. So again please note that just like in case of the columns, this third row represents the case where x3 and x4 is equal to 1 1, and it's not 1 0, it's 1 1, and it is done so that only one variable changes as we move from one row to the other. If we would have said that the third column represents the case where x3 and x4 is equal to 1 0, then both the variables would have changed when we move from row 2 to row 3. Since this row corresponds to the case where x3 and x4 is equal to 1 1, the 4 cells in this row will represent the input combinations 0 0 1 1, 1 0 0 1 1 1, 1 1 1 1 and 1 0 1 1. The next row corresponds to the case where x3 and x4 is equal to 1 0. hence the cells in this row will represent the input combinations 0010, 0110, 1110 and 1010. So now we have determined which input combination each of the cell represents. One thing to note is that the first and the fourth column, which are highlighted here, are actually adjacent to each other. If we look at the values of x1 and x2 in these two rows, only one of the variable changes between the two rows. So these two rows can be considered to be adjacent to each other, which means these two cells are adjacent to each other. Same thing for these two cells, and these two cells also, and these two cells. So the highlighted cells are adjacent to each other. So when we try to make groups of 1 to come up with the minimized sum of product expression, when we try to make the groups of 1, we can consider these cells as adjacent to each other. The same thing for these two rows. The two highlighted rows are also adjacent to each other, which means these two cells are adjacent to each other. The next two cells are also adjacent to each other. The two highlighted cells are also adjacent to each other. And finally, these two cells are also adjacent to each other. Now, since we know which input combination each of the cell represents, we can also tell which minterm each of the cell represents. For example, the first cell represents the input combination 0000, and hence it represents the minterm 0. The next cell where the input combination is 0001 represents the minterm 1. And then this is minterm 2. This is minterm 3, 0011. 0100 will be minterm 4. 0101 will be minterm 5. 0110 will be minterm 6. 0111 will be minterm 7. And then please note that as we move to the next row, after M7, M8 will be in the fourth column. So minterm 8, minterm 9, minterm 10, minterm 11, minterm 12, 13, 14, 15. So you please note these in what order we do the counting. So this is 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have seen which minterm each cell represents. Now let us do one exercise where we try to find out the minimum sum of product expression for a given Boolean function. And the Boolean function is given here is the sum of the minterms 2, 3, 9, 10, 11, 13. The first thing we have to do is represent this function in the Karnaugh map. And when we represent this function in the Karnaugh maps, the meaning of this sum of minterm expression is that the Boolean function f is equal to 1 for these minterms. So for minterm 2, the value of f is 1. For minterm 3, the value of f is 1, and so on. So for each of the minterm here, the value of f will be 1, and for the other min terms the value of f will be 0. So since min term 2 is represented by in this particular cell, and this cell will have the value 1. The next min term 3 will also have the value 1. The min term 9, which is in this cell, will also have the value 1, and then min term 10 will also have the value 1, min term 11 will have the value 1, and min term 13 will have the value 1, and the remaining min terms will be equal to 0. So this is how the given Boolean function can be represented in the Karnaugh map. Now once we represent the Boolean function in the Karnaugh map, the next step is to make groups of 1. We want to make groups of 1 because we are interested in finding the minimum sum of product expressions. If instead of sum of product expression, if we want to find product of some expression, then we would make groups of zeros. Here we want to find the minimum sum of product expression, so we will make groups of ones. And when we make groups of 1, we can make groups of size 1 or size 2 or 4 or 8, 16 and so on. And when we make the groups, we try to make the group as large as possible, because a larger group will give a more minimized expression. So now given this Karnaugh map, you may be thinking to make groups. This is one group. This is one group of size 2. And then you may be thinking of making this one group and the next one group. However, this would not be the correct way to make the groups, because this will not result in a minimized Boolean expression. The correct way would be to make all these 4 cells into one group. As we had already discussed, column 0 and column, if you call it column 1, column 2, column 3 and column 4, so column 1 and column 4 are adjacent to each other, and these cells were adjacent to each other, so we can combine all these 4 cells into one group. That way we will have a bigger group. So this would be the correct way to make the groups. Now once you make the groups, the next step would be to find the product term for each group. And now to find the product term, this cell from the blue group consists of 2 cells, and the first cell represents the min term x1, x2, x3 prime, x4, and the next cell in the blue group represents the min term x1, x2 prime, x3 prime, x4. And now when we compare these 2 min terms, we see that the variable x1 is appearing only in the uncomplemented form, whereas variable x2 appears both in complemented and uncomplemented form. Variable x3 appears only in the complemented form, and variable x4 also appears only in the uncomplemented form. Now since variable x2 is appearing in both complemented and uncomplemented form, we can discard this variable. The other variables, they are not changing between the 2 cells, so the other variables will not be removed. Hence we are left with this product term, which is x1, x3 prime, x4. This means that the blue group can be represented by the product term x1, x3 prime, x4. The red group has 4 cells, and this particular cell can be represented using the min term x1 prime, x2 prime, x3, x4 prime. The next cell can be represented by the min term x1 prime, x2 prime, x3, x4. This particular cell can be represented by the min term x1, x2 prime, x3, x4 prime, and finally this last cell in the red group can be represented using the min term x1, x2 prime, x3, x4. Now when we look at these 4 min terms, we see that x1 is appearing in both complemented and uncomplemented form. So x1 can be discarded. x2 appears only in the complemented form, so x2 will not be removed. Similarly, x3 appears only in the uncomplemented form, so x3 will also not be removed. However, x4 appears both in the complemented and the uncomplemented form, so x4 will also be removed. That leaves us with this product term x2 prime, x3, and the red group will be represented by this product term. Now we have the product term for each of the 2 groups. Now I can write the minimized sum of product expression as f, which is a function of x1, x2, x3, x4, is equal to x2 prime, x3 plus x1, x3 prime, x4. So this is the sum of these 2 product terms. One thing you should note is that when our groups are of size 2, one of the variable gets discarded. When our groups are of size 4, 2 variables gets discarded. If we have a group of size 8, 3 variables will get discarded, and so on. So with this, I would like to end today's class. Actually, we will look at few more examples of minimization of 4 variable Karnaugh maps, and we will look at as a part of our class on BCD277 display decoder, and that will be in our next class. We'll look at few more examples of minimization of 4 variable Karnaugh maps, 4 variable Boolean functions. And with this, I would like to end today's class. We'll meet again in the next class. Thank you. Bye.